Hello guys, welcome back to GSA Goze Science Academy. In this video, I'm going to continue with what I started in the last video talking about logarithm. But in this particular video, I'll be focused on solving some more complex problems that has to do with logarithm and logarithmic equations. As you can see on the screen, we have 5 interesting questions here, and all of them has to do with logarithm. By the end of this video, I assure you that you're going to have a very intense strength to solve questions and equations that has to do with logarithm. So the first one is solve for x and y given that the logarithm 27 base x plus logarithm of 4 base y is equal to 5, and the logarithm of 27 base x minus the logarithm of log 4 base y is equal to 1. So the second one is express y in terms of x if the logarithm of y minus 1 base 3 is equal to x. The same thing here, express y in terms of x is 1:2 logarithm of y plus 3 base 2 is equal to 2x. Number 4 says show that log b base a multiplied by log a base b is equal to 1. We are going to show this, we are going to prove it. So show that, this is also show that p, the logarithm of p to the power of x minus n base a plus the logarithm of p to the power of y plus n base a is equal to the logarithm of p into x plus y base a. So the last video I did, I'm going to drop the link here so that you can get it and learn the laws of logarithm, because we are going to be applying the laws of logarithm to solve this problem a whole lot. So let's jump right into the solutions to this problem. I'm going to start with the first one. So let's go right. Solve for x and y given log x to 27 plus log y 4 is equals to 5 and this. So let's go into this question. So let's solve the first one. So we have two equations. The first one is log 27 base x plus log of 4 base y is equal to 5. And then this is the first equation. This is the second equation. We have log 27 base x minus log of 4 base y is equal to 1. So this question is pretty very simple. The first thing I'm seeing here, we are solving this together. I'm saying that we have log 27 base x and log 4 base y. And the second thing I can see here is we have two different equations and we're looking for two variables, two unknowns, x and y. And that brings in the thought that this is a simultaneous equation. So we have to solve this equation simultaneously for us to be able to get the value of x and the value of y. So let's do something. Let's solve this. So before I go into identifying which of them is equation 1 and giving any of them to be equation 2, I need to change these logarithms. From this, I need to change the equation from its logarithmic form to its index form so that it will be easier for me to solve. So what do I mean by that? So let's recall, let's say that the log of 27 base x is equal to p. I want it to be p. Let's give it that. And then let's say that the log of 4 base y is equal to 1. Let's give it that. So this is what we are just it's equal to q. It's equal to q. So let's just give this. So we can substitute now to the original equation given to us. So if we do that original equation given to us, log 27 base x. So in place of that, we put in p. So we have p. So I'm just taking these guys back right into what we have. So this is p plus log 4y base y is q. So this is q. And this is equal to 5. This is equation 1. So the same thing happened here. This will be p minus q, and this is equal to 1. So I call this equation 2. So this now becomes simple for me to solve simultaneously. I don't want to write too much. So I'm going to use the elimination method of simultaneous equations. So I'm going to make a video on how to solve simultaneous equations. I'm going to post the link within 3 days after this video. So I'm going to post it there. So I'm going to make a video on that. So let us just do this. But you have to learn simultaneous equation. So let's use elimination method. So I'm going to subtract equation 1 from equation 2. If I do that, I'm going to have p subtract, that is p minus p is 0. Then q minus q is 2q. Is equal to 5 minus 1 is 4. So if I solve for q in that, we have that q is equal to 4 divided by 2, and that makes q to be equal to 2. So we have the value of q to be equal to 2. So let's solve now. We are going to substitute q equal to 2 into any of these equations. So I'm going to substitute it into equation, let us say equation 1. So I'm going to substitute it into equation 1. So we have that q. So we have q is equal to 2. So I'm going to substitute q equals to 2 into this equation, into p plus q is equals to 5. So I'm going to substitute it into p plus q is equal to 5. So we are substituting q equal to 2 into this equation to solve for p. So if we do that, we have p plus 2 is equal to 5. This is 5. So if I solve for p is equal to 5 minus 2, which is equal to 3. So we have that q is equal to 2, and then we have p is equal to 3. Can you hear the crowing of the chicken? The fowl? It shows that this is morning. This is 6 a.m. or I think it's 5 a.m. or so. So let's continue with the video. So we have been able to establish that q is equal to 2 and p is equal to 3. But recall, I want us to recall what we stated initially. So initially, we stated that log 27 base x is equal to p and log y base 4 is equal to q. So we're going to bring in that back so that we can be able to solve. So we accepted that log of 27 base x is equal to p. So if this is true, now p is equal to 2, so we're going to solve for p there. So we accepted that log x base x of 27 is equal to what? P. So p is equal to 2. We know we have solved for that. P is equal to 2. So substitute it there. We have the log of 27 base x is equal to 2. So I'm going to convert this to its index form so that I can get the value of x. If I do that, we're going to have 27, which is the number. I've taught this on a previous video. I recommend you go to that video before coming here. It will make it very easier for you. So I've taught how to change from logarithm form to index form, and that's what I'm just repeating here. So 27 is equal to, so this is x, which is the base. X is the base, and this 2 here is the power. Is the power 2. So now the next thing we are here to check out for to solve is we want to know what is 27. What will be 27? So let us check the value of p. So I'm sorry, the value of p is actually 3, not 2. the value of p is actually 3, not 2. This is 3. Okay, value of p is 3. It is q that is 2. So now we have this. Sorry for that. So this is 27 is equals to x to the power of 3. So what is x? So what number? The question you ask yourself is, what number to the power of 3 will give me 27? What number to the power of 3 will give me 27? And that is 3. Because 3 to the power of 3 is equal to 27. I just want to make the powers to be alike so that I can equate for x. So since the powers are alike, we conclude that x is equal to 3. That's very simple. So we solve for q. So recall we say that log of 4 base y is equal to q, and we have solved for q that q is equal to 2. So all we have to do is to substitute it here. If we do that, we're going to have the log of y. Now 4 base y is equal to 2, the same thing we did previously. So we convert this to its index form. We have it to be 4 is equal to 2 to the power, that is y to the power of 2. So y is the base there. So y is the base, y to the power of 2. So what number y is raised to the power 2? What number raised to the power 2 will give me 4? So that is because this is the same thing as saying 2 is to the power of 2. True, and this is the same thing as saying this is y to the power of 2. So as you can see, the base are the same. So y is equal to 2. So very simple. We have that x is equal to 2, and then we have that y is equal to 3. So let's go to the next question. So the next question we have is we want to show, I think I've gotten it, we want to express. So I still have it on my screen. We want to express y. Now we have log. If we have log of y minus 1 is equal to x, this is base 3. So we want to express y in terms of x. So we want to make y the subject of formula here. So we convert this to its index form. We have that y minus 1 is equal to 3 is the base, 3 to the power of x. So because we are making y to be the subject of formula, we take minus 1 to the right hand side. So we leave y is equal to 3 to the power of x plus 1. So this is the answer. So this is the value of y in terms of x. And the second question says we should express 1:2. If you still have, you can forward back to check the questions. You see it's the same thing. So we want to show that we want to express y in terms of x here. 2, this is y plus 3 is equal to 2x. So expressing y in terms of x is simply trying to make y the subject of this equation. So according to laws of indices, this is the same thing as saying of logarithm. This is the same thing as saying logarithm of y plus 3. So this 1:2 will be the power. 1:2 power is equal to 2x. So things now become simple for us. So we can make y, we can change this to its index form. We are going to have this to be y plus 3 to the power of 1:2 is equal to 2 is the base, so that is 2 to the power of 2x. So I want to make y sort of formula, so I'm going to square both sides. If I square both sides, so I'm going to square both sides. So square both sides. So square both sides So if we do that, if we square this, we are going to be left with y plus 3 is equal to, if I square this, I'm going to be left with 2 to the power of 2x all square. So all square. So I'm going to be left with, so I'm going to make y search of formula. So I'm going to take minus 3 to this part. So I have that y is equal to 2 to 2x. This will multiply, the powers will multiply themselves. Will be left with 2 to the power of 4x. So this minus 3 will come over to this part. Plus 3 will come over to be minus 3. So this is the answer. This is the value of y. This is the value of y. Okay, nice and beautiful. We move on to the next question. I still have all of them. So the next question we are looking at is showing. So let's get rid of this. So we want to show this. We want to show that the log of b base a multiplied by the log of a base b is equal to 1. So I want you to recall one of the laws of logarithm I made in the previous video. So recall that the log of b base a is equal to, this is one of the laws, to the reciprocal of the log. Now I'll make the base to be the number and the number to be the base. So that is a base b. So this is one of the laws of logarithm. So I'm going to substitute it to this guy. So in place of this b base a, I'm going to put in this. So if I substitute this and take it into this equation, so we're going to have, in place of log b base a, and we're going to have 1 divided by log. We can actually show this too, but I don't have, but this can also give you your marks straight up. So anybody that sees this will know you're very conversant with your laws of logarithm. So this is 1 is a base b, multiply by log of b of a base b. This is log. This is the same thing as saying over 1. So if I cancel that, you can see that this is equal to 1. So everything there is equal to 1. So we have been able to show that the left hand side is equal to the right hand side. So very simple problem. So let's go into the next question. So the next question is actually the same thing. We are actually showing the left hand side is equal to the left hand side if the log, so this is the last question, this is the log of p to the power of x minus n base a plus the log of p to the power of x plus n base a. So we want to show that this is equal to the log of p multiplied by x plus y. This is y. So let's show this. We want to show that let's show that the left hand side is equal to the right hand side. So we are going to work with the left hand side. So this is log a b. So this is the same thing according to laws of logarithm. This is the power. X minus n is the power, and this power, according to laws of logarithm, you remember that if we have the log, of a number to p to the power of n, I did it in my previous video. This is the same thing as saying n multiplied by the log of that number base a. So this law, so we're going to apply this law here. So if we do that here, this x minus n is the power, so we have it to be x minus n, which is the power, then log p, so we get rid of the power, is a, then we get rid of the power. So the same thing will happen here. So this is the power y plus n, so we'll bring it to the back and multiply it by everything, y plus n into the log of p base a. So let's create space. Let me get rid of that. So if we do this now, we solve this. So I'm just going to factor this log p base a, log p base a. So if I factor it out, I'm going to be left with log p base a. I factor it out. So this is x minus n and plus y plus n. So that is simple. So we're going to solve that. So that is x minus n plus y plus n. So if we solve that, this is minus n, so that is minus n plus n will be off. So we are left with log, if we take like terms, log p into x plus y minus n plus n. So if we give me log of p base a into, so this will be off, so we are left with x plus y, which is what, as you can see, this is the right hand side, which is what, the right hand side. So that comes to the end of this video. Thank you very much for watching. Make sure you subscribe to this channel because we are looking up to